yesterday. Turn to someone in front, behind, beside you. Tell them how you know whether it's a vertical asymptote or a hole. Turn. Dustin, your earphone needs to come out. I think I heard lots of good stuff in there. Vertical asymptotes are when?
Vertical asymptotes when they don't cancel.
When it doesn't cancel. If it cancels, it is a hole. We're going to talk now about horizontal asymptotes versus oblique asymptotes, and you're going to have three different possibilities. The first possibility, the degree of P of x is 1 less than the degree of Q of x. I'll explain what that means in a second. Sean, put your phone away. The degree of P of x equals the degree of Q of x. And the third possibility, the degree of P of x is 1 more than the degree of Q of x. There are other situations. These are the only three you're going to run into this year. It's going to be one of these three cases every single time. Now, I totally screwed up and mixed up these examples, so we're going to cross them out and write new examples. See, I'm not perfect. I know. It happens. Sorry? Yeah, and I forgot to change it. If I don't change it the day of, I completely forgot. P of x means the numerator, Q of x means the denominator, and let's talk about what the degree of a polynomial means. You learned this way back in grade 9. What is the degree of a polynomial? For example, a quadratic, which we looked at 1,000 times last year, has a degree of 2. A cube, we learned this year, has a degree of 3. A linear function has a degree of 1. What's the degree of a polynomial? What's the definition? It's the highest exponent is the degree. So what situation 1 means is that the degree on the bottom is 1 more than the degree on the top. So an example, we could have a linear function on the top, x plus 4, totally making that up. And then we would have a polynomial on the bottom, x squared plus 7. That's situation number 1. I call this degree over degree plus 1. That's how I remember it in my head. So the degree on the bottom is 1 more than the degree on the top, degree over degree plus 1. If it's that situation, it's a horizontal asymptote. And it's always going to be at y equals to 0, which is the x-axis. So these are the ones you met last year. You just didn't know it.
Sorry for the interruption. Mr. Weed, please contact the office, please. Mr. Weed, please contact the office.
The second situation is when the two degrees are the same. I call that degree over degree. So you might have a linear on the top and a linear on the bottom. You might have a quadratic on the top, quadratic on the bottom. So here's an example. That also means it's a horizontal asymptote. It just means it's a number other than 0. And what it's equal to is the leading coefficient of P of x dividing by the leading coefficient of Q of x. And I'll explain that when we get to the example. What it means is it's not at 0, it's someplace else. The third possibility is the opposite of number 1, that the top is 1 more degree than the bottom. So I call that degree plus 1 over degree. So an example, you could have a quadratic on the top, which means you'd have a linear function on the bottom. That's degree plus 1 over degree. That means it's not a horizontal asymptote. It's what we call this oblique asymptote. That's the only time you're going to have an oblique, when you have 1 degree higher on the top than the bottom. And we're going to use this thing called synthetic division. That's the part at first you're going to be like, whoa, what is going on? But you're going to see after a couple examples it's really easy. It's just overwhelming at first. Andrew.
Is it possible for there to be more than one horizontal asymptote?
No. Good question.
Is it possible for there to be both a horizontal and oblique?
No. Good question. These are the only three situations you're going to run into. Degree over degree plus 1 means it's a horizontal asymptote at y equal to 0. Degree over degree, meaning they're the same degree. It's also a horizontal asymptote. It's just not at 0. It's somewhere else. Degree plus 1 over degree means it's this oblique or slanted asymptote, and I'll show you how to find it in a second. Okay, so we're going to do exactly what we did yesterday with vertical. We're just going to do it now with horizontal. So we're going to identify any horizontal or oblique asymptotes for the following rational equations. Do you got your paper? What? Like you're all ready? You have it? I don't know what to do with this. What your gut is going to want to do here is factor, but that's for vertical asymptotes, and that's not what we're finding in these. We're finding oblique or horizontal. So we do what's called analyze the degree. What's the degree on the top? What's the highest exponent on the top function? What's the highest exponent on the bottom? So we call this degree over degree plus 1. Degree over degree plus 1. Go back to this little table here. Is that case number 1, case number 2, or case number 3? That is case number 1. And you don't need to write this out. I'm just walking you through the thought process. If it's case 1, that tells you it's a horizontal asymptote, not an oblique asymptote. And it tells you where it is. It's y cannot be 0. That's it. That's all they want for the first question. No, because we've already done that. We've practiced that. We'll do that when we come back to graphing this afternoon. We're just practicing horizontal and oblique. Letter B, y equals negative x squared plus 5 over x minus 2. Degree on the top, degree on the bottom. So I call that degree plus 1 over degree.
That's case number 3, folks.
Agree that it's case number 3? Okay. I would not normally write any of this. This is just the thought process to figure out that it's case number 3. Case number 3 tells you it's not a horizontal asymptote, it's an oblique asymptote. Put your pens down and watch me do this, and then I'll do it again with you. But I just want you to watch it first because this is new, and at the beginning it's like, what the heck? Just trust me on this. It's going to become easier. I'm going to do what's called synthetic division. What does the word synthetic mean? Fake. So if you have synthetic leather, that's called fake leather. What do we call that? Vinyl. Right? If you have fake anything, it's called synthetic. So I'm going to do long division that you learned in grade 5. I'm just going to fake it a little bit. Okay, follow with me here. What I'm going to do is do an upside down division sign. Now, what's totally weird is that's actually the correct division sign for the rest of the world. We do it upside down, so it's kind of weird because he's like, what? That's normal in Poland. That's how they do it. Just go with me here. It's just an upside down division sign to us. Then I'm going to take the polynomial in the front, and I'm just going to write the coefficients in order. So in front of the x squared is a minus 1. In front of an x, which I don't have, is a 0, because I don't have any x's. And the constant is 5. Are you still with me?
No.
Which part did I lose you at?
Start from the division part.
Upside down division sign. Just put an L with a really long bottom. Then inside, I'm just taking the coefficients of the top. I have negative 1x squareds. I have no x's, and I have 5 as a constant. So this is my x squareds, my x is my constant. Then I'm going to put a number on the outside, and the number is going to come from taking the bottom, equating to 0, and solving. So if it's x minus 2 equals 0, what does x equal? 2. So I'm going to put a 2 on the outside. The first number I'm going to drop straight down. Then I'm going to multiply by the guy on the outside, and I'm going to put him in the next column. So what's 2 times negative 1? Then I'm going to add vertically. What's 0 plus negative 2? Then I'm going to repeat the same process. I'm going to multiply by the guy on the outside and write him in the next column. So 2 times negative 2. And I'm going to add vertically. You with me so far? The only 2 numbers I care about are the first 2. The only 2 numbers I care about are the first 2. And an oblique asymptote is just a straight line. And what's the equation for any kind of straight line? Y equals mx plus b. The first number is m. The second number is b. So my oblique asymptote is y equals negative x minus 2. Again, at the beginning, I know it's like there's a lot going on. The more you do these, you're going to see it becomes really easy. Now write in, I'm going to redo it with you. Upside down division sign. And the top of that is the coefficients of the polynomial in order. So I have minus 1x squareds. I have no x's. And I have a constant of 5. And just because this is our first one, I'm just going to make a few notes as we go along. This is the x squareds. This is the x's. This is the constant. And these are always the numbers from the numerator. The number on the outside and the left comes from the denominator, and we equate the denominator to 0 and then solve for x. So it's really finding the restriction on the bottom. That's where it's coming from. So if x minus 2 equals 0, what does x equal?
2.
Okay, so just making a note, this is always from the denominator. And it's the NPVs. So equate to 0 and solve. First number drops straight down. You're always going to take the number at the bottom, multiply by the guy on the outside. So minus 1 times 2 is minus 2, and he goes up into the next column. Then I'm just going to add vertically. 0 plus minus 2, minus 2. Then I'm going to repeat the procedure. 2 times negative 2, minus 4. Add vertically, 1. In theory, for this last column doesn't matter, so I could stop here, but this will come back to us in Unit 5 where the last one does matter. That's why I'm keeping going. But in theory, I don't care what's in this last column. All I care about is the first two numbers. The first number is always your m value, and the second number is always your b value. And this will always give you the equation of a line, so it's y equals negative x minus 2. Again, I know it's weird at first. Andrew?
What if the denominator is quadratic?
We won't have those because then it means the top is cubic, and we won't run into cubic over quadratic. How are we doing so far? We are done this question because all it wants us to do is identify the horizontal or oblique asymptotes. This has an oblique asymptote. There it is. I hate case number 3 too. It's a lot of work, but they come up.
Yeah, we have to do some fake division. Hopefully we don't get sued.
Letter C, negative x squared plus 5 over 3x squared. What's the degree on the top? What's the degree on the bottom? So we call this degree over degree. Case 1, 2, or 3. And again, you don't need to write that down. That's just thought process to figure it out. What it tells us, there's an oblique or a horizontal asymptote. It's just not at 0, it's somewhere else. Where it is, it's what's called the leading coefficients of top and bottom. Leading coefficient is the coefficient attached to the term that has the highest exponent. It's the coefficient attached to the term that has the highest exponent. So on the top, our leading coefficient is the negative 1 that we don't see. On the bottom, the leading coefficient is 3. So the horizontal asymptote becomes y cannot be negative 1 from the top divided by 3 from the bottom. What it tells us, it's not at 0, it's at negative 1/3. That's how case 2 is always going to work. It's the two coefficients of your leading degree or your leading term.
I think the math is easier to understand than some of the terminology.
There's a lot of terminology in this. But again, you're going to see once we do a few, they're going to become really easy.
I feel sorry for those poor exchange students.
But they've done this like 6 years ago. You know, let's be honest. Degree on the top, 2. Degree on the bottom, so degree plus 1 over degree. Case 1, case 2, case 3. I side 2 when I get case 3. It's not just you. Oop, degree plus 1 over degree. Upside down L. Inside are the coefficients from the top. How many x squareds do we have? How many x's do we have?
6.
What's the constant? Number on the outside comes from the NPV of the denominator. So what does x equal on the bottom? See, already you're getting this. I always change colors. I don't know why, just the way my brain works. The first one always drops straight down. Then it's a multiplication by the number on the outside. So 1 times negative 2, negative 2. Add that column, 6 plus negative 2. Again, in theory, we can stop here. I want to keep going because it's how we're going to do it later. 4 times negative 2. Add vertically. Ooh, negative 15. All I care about is the first two numbers, and that gives me the oblique asymptote. So the oblique asymptote is y equals.
X plus 4.
See, already just the second one, and already you're starting to get it. Andrew, question or stretch?
Stretch.
Okay,
It's the morning. I'm tired.
fair enough. I am too.
Hopefully we get a day off.
It's kind of nice to have a day off in the middle of the week, actually. What? No?
Weird as well.
I'm kind of
that
enjoying.
One day later, we'll have to be right back here.
And then you get Friday off, and I don't get Friday off. But Austin?
What's with this weird week? Who made this schedule?
Tomorrow doesn't work out for us. So Thursday we have no class in the morning, right?
Ask again, sorry. Thank you. Yes, because it's an asymptote. Absolutely. Yes, tomorrow does not count as a day. Friday does count as a day. So check your calendar so that you figure out the doubles.
So Thursday's a single, and so Thursday and Monday are both singles.
I don't know. That's why I put it on the calendar for you. Honestly, I just teach whoever shows up.
Which once again doesn't include Gunther.
Poor Gunther. Degree on the top. Degree on the bottom. Case 1 or case 2 or case 3.
Case
We're doing lots of these to practice.
we're getting a lot of case 3s.
Just to practice, because this is new. Okay, numbers on the inside come from the numerator. How many x squareds do we have? How many zeros do we have? Oh, how many x's do we have? What's the constant?
-4.
Where does the number on the outside come from? From the bottom. What can x not be, or what's the NPV? 1 always drops straight down. Then we multiply by the guy on the outside, which gives us. Add that column. Multiply by the guy. Oh, you're already ahead of me. None. Y cannot be.
X minus 3.
Do you see how you're already getting it? Right, it's third example.
It works. It's fake division really works.
It's not mine. I didn't invent it.
Who invented fake division?
I don't know. Know that one.
Although I think the term fake division
Is it considered?
Yeah, could be. Could be. Really? Like from grade 4?
I don't remember.
I will in unit 5 when it becomes really important. Real division doesn't matter now, but it will in unit 5.
Or subtracting, like long, big subtracting.
Which the carrying and the borrowing?
Yeah. I remember.
Let's go to example 3. What we're doing is putting these ideas together. So now we're going to find NPVs. We're going to say are they asymptote holes. We're going to find horizontal and oblique asymptotes. And I'm going to add in intercepts. This is theory for what we're going to do this afternoon. So we're just practicing the build up to the actual graphic.
and we're going to do fake division as well.
We might, only if it's case number 3.
Which
What's the odds we get a case number 3?
1 in 3. Hey, technically it is 1 in 3 given that there are 3 cases, Shiles.
Well, it wouldn't technically.
I'm left-brained, so I use columns because it's the way my brain works. If you're right-brained, doesn't matter. I don't care. You can do it any way you want to do it. The first column is always going to be vertical asymptotes or holes. Second one is horizontal asymptotes / oblique asymptotes. And the only thing I'm adding in that we haven't talked about yet is intercepts, but you've been doing those since grade 10. You don't need to use columns. It's just the way my brain works because I like to compartmentalize. If you like to do it differently, do it differently. I don't care.
Is there going to be enough room in those columns for fake division if it's necessary?
Do you think I would set up columns that weren't long enough? Do you think my brain would allow me to do that? Yeah. Okay, vertical asymptotes as holes is what we did yesterday. What's step 1 for vertical asymptotes and holes? Factor anything you can. So can we factor the top?
Yes.
How can we factor it?
Common factor.
X plus
Can we factor the bottom?
No.
What does that tell you about the bottom?
That there may or may not be a vertical asymptote.
Is it a vertical asymptote or is it a hole? It's a vertical asymptote. How do we know? Because it doesn't cancel. And where is the vertical asymptote? 4. Okay, so that's what we did yesterday. The middle column is what we're adding in today, and your brain's going to want to factor no. That's not how we do horizontal or oblique. What we look at is the degrees. What's the degree on the top? What's the degree on the bottom? So this is degree over degree. For now, until you know this, look back at the chart, figure out what case it is. Which one is degree over degree? It's case number 2, so that tells us we have a horizontal asymptote. It's just not at 0. How do we find it? This is the leading coefficient. So we go to the top, get the leading coefficient, which is 2. Leading coefficient from the bottom. And I'm just going to put imaginary 1 because we know we don't need to write it. And so we would say this is y does not equal 2. Are we okay so far? Okay, so this is what we did yesterday, this we did this morning. Intercepts you've been doing since grade 10. How do you find an intercept? Let's start with y-intercept. How do you find a y-intercept? Put x equal to 0, solve for y. So keeping y, I'm going to put 2 times 0 plus 2 on the top. And on the bottom is 0 minus 4. Two times 0 plus 2. So I have 2 on the top. 0 minus 4 on the bottom. Can we reduce or simplify?
Yes.
What I like to do is I like to write this as a coordinate point so that my brain understands it's not an asymptote. So I'm going to put the coordinate point 0, negative a half. Okay, because when we go to graph, you need to keep in your head what's an asymptote versus what's an intercept. So intercepts are points on the graph.
It's pretty easy to figure out what's not an asymptote.
Yeah.
If it's not an asymptote, it would say y equals and not y is.
True, but sometimes we get a little sloppy with that. So this is clearly a point when we write it like that. Again, you don't have to. You can do what you want for your example. I'm just giving you hints. You don't need to show this work. What I do for x-intercepts is I just cover everything with an x because you know they're going to be 0. So what's left? 2 over negative 4. Reduce it, negative a half. So you don't need to show this work if your brain can see it. If your brain can't see it, feel free to show the work. X-intercepts. How do we find an x-intercept? Y equal to 0. So now there's going to be a 0 on the left, and everything on the right is going to stay. Some brains find this easier to see when you bracket the top and bottom, because sometimes then you can see it's a binomial. If you don't need to do that, don't do it. I'm going to start with the bottom. I want to clear the bottom. So what's the opposite of dividing something by x minus 4? So I'm going to multiply, in theory, both sides by x minus 4. What happens on the left? What's anything times 0? And on the right, that binomial is going to go. So in essence, what happens with these is the denominator vanishes. That's always going to happen with your x equals. The denominator is going to vanish because you're multiplying it to the other side. How do I get rid of a plus 2? How do I get rid of a coefficient of x? So x equals? And again, I like to write that as a coordinate point to get really clear in my head that that's a point we're going to plot. It's not an asymptote. It's not anything else. It's a point on the graph. How are we feeling so far? Again, lots of theory, I know. Okay, let's go on to the next one. You don't need to use the columns. You don't need to use the headers. You can do however makes sense to your brain. Vertical asymptotes and holes. What's the very first step? Factor anything you can. Do you hear music as well? Okay, just checking. Do I have an offer for the top? Offer of x plus 2, x minus 1. Vertical asymptote or hole? Why?
So the vertical asymptote would be -1.
Sorry, Shaz, which one were you asking? It's an x, it's just kind of a yucky x. No, vertical is always x. Vertical goes with x. Again, what's going to happen is your brain is going to want to do some canceling here, because that's what we did last year. We factored these rational expressions and we canceled everything we could, and lots of stuff did cancel. If it doesn't cancel, it doesn't cancel. It just means it's a vertical asymptote. Horizontal or oblique, what's step number 1? Analyze the degree. The top is a degree of 2, bottom is a degree of, we call that degree plus 1 over degree.
Otherwise known as case number 3.
Case number 3.
Otherwise known as fake division.
Okay, upside down division sign. What are the numbers I'm going to put inside at the top? What's the number I'm going to put on the outside? Drop the 1, multiply by the -1. So 1 times -1. Add that second column, 1 -1.
0.
Multiply by the number on the outside, 0 times -1. Add that column, -2 plus 0. You'll notice this time I didn't put those arrows. If your brain needs them, put them. If you don't need them, don't put them. All I care about is the first 2 numbers. So my oblique asymptote is y cannot be. How are we feeling so far? Is this getting easier? Good. Intercepts. I always start with y. I don't know why. I just do. Again, what I do in my head is I just cover everything that has an x because I know they're all going to turn out to be 0. So just to speed up the process a little bit, what's left on the top that doesn't have an x? A -2. And what's on the bottom that doesn't have an x? A 1. Simplify it, -2 divided by 1. And then I like to write it as a point, 0 minus 2. Again, if you want to sub in that 0 and do the calculation, that's fine. This is just one way to speed up if you can. X-intercepts. I completely ignore the denominator. Why? Because it's going to multiply over and become 0. So all you're really interested in is in the numerator. It's quadratic. How many ways are there to solve a quadratic? There's 5. What's the first way? Factoring, graphing, square root, complete the square, quadratic formula. Well, you already factored over here. So that's the easiest one to do because you've already done half the work. So we know that it's x plus 2 over x minus 1 times x minus 1. Split and solve, x equals -2 and x equals 1. And again, I like to write these as coordinate pairs to remind myself that they are points on the graph, nothing else. This is as hard as they're going to get, by the way. This is hard. That's it. Vertical asymptotes and holes. What is step number 1? Yeah, so factor everything that you can. Can we factor the numerator? Can we factor the denominator?
Yes.
Does anything cancel? What does that tell us about x plus 3? Oh, I copied it down wrong. Sorry, there's a minus up here. Where is the hole?
Would it be x is not equal to if it's a whole?
Yeah, we tend to. It's a point, a coordinate point, so it doesn't really matter so much. Now the problem is, I only know the x coordinate of this hole. I don't know where it is on the y scale, so I need to find the y value. Go back to the original question, and I want you to keep the factored version. So because these canceled, I'm left with a 1 on the top, and I have an x minus 3 on the bottom. And I want you to highlight that. I want you to circle it. I want you to put some glitter glue around it, put some flashing lights. We go back to the factored form to find everything else now. So to find the y coordinate of the hole, I'm just going to substitute into the factored form. So I'm going to put my negative 3. Which means I have negative a sixth. Are we okay where that's come from?
Wait. Oh, the negative 3 is the
The negative 3 is where the hole is, and I just want to find its y coordinate, so I just subbed in negative 3. If you go back to the factored form, and you sub in negative 3, what you're going to end up on the bottom is 0. And can we divide by 0? No, that's why we have to go back to the factored form. Plus, it's, why wouldn't we want to go back to that form? So I'm going to write this as a coordinate pair, because it's not an asymptote, it's a hole. And the way I visually remind myself that that's a hole and not an intercept is I just put a little hole in front of it. Okay? You don't have to do that. That's my notation to remind myself when we graph, that's a hole in the graph. We still got to talk about this x minus 3. Did he cancel?
No.
So what is he? He's a vertical asymptote. X cannot be
Positive 3.
positive 3. There's the difference between a hole and a vertical asymptote. A hole is a coordinate point on the graph. Vertical asymptote is a vertical line. Yes, sir? So I took the value of the hole, and I just subbed it into the factored form to find the y value. So I put in negative 3 in the bottom, and then negative 3 gave me negative 6. So it's just finding the y coordinate. Okay, analyze the degrees.
Which form?
Doesn't matter. Well, let's check. If we go back to the original, what's the degree on the top?
1.
1. What's the degree on the bottom? So what case is that?
1.
Degree over degree plus 1. Okay, let's check the factored form. What's the degree on the top?
0.
X to the 0 is, so it's 0. Degree on the bottom is. So it doesn't matter which one you check. It's still going to be degree over degree plus 1. Case number 1, case number 2, case number 3. Case number 1 is the bestest. It's the least amount of work. Y cannot be 0. How are we doing? The y-intercept x is 0. I go to the factored form because it's less work. I don't have to think as much as the other one. Put in a 0 for the x. What do we end up getting? Negative a third. Okay, so that's the point 0 minus 1/3. I could have chosen to go back to the original. I would have had 3 over negative 9, which would have given me the exact same value. Zero on the left. Everything else on the right. What's going to happen to that denominator? He's going to go over and become 0. 0 equals 1. What does that mean?
Math's broken.
Yeah, well, you probably think you've made a mistake, so you'll do the question again, and you'll get the same thing, and then you'll do it again, and then you'll call me over in a panic and say the question is broken. No, what does this mean in terms of the graph? There's no x-intercept, and that's okay. There's lots of graphs that don't have an x-intercept. No x-intercept, just doesn't cross the x-axis, and that's okay. If you think of volcano, does it cross the x-axis? No, so that's okay that you don't have an x-intercept.
So I bet if I went to calculator and
No, don't peek. Don't peek yet. Don't spoil the fun. How are we doing? The fourth one. Oh, I already had a piece of paper. Oh well. Because we like to work up so we don't scare you. How do you know it's the most complicated? Because there's lots of stuff. Step 1 for vertical asymptotes and holes. Factor. Turn to someone in front, behind, beside them. Tell them how to factor this.
x plus 3 times x minus.
There's what I heard people saying for the top. Right, wrong, agree, disagree. Here's what I heard people saying on the bottom. Agree, disagree, like it, don't like it. Huh? What huh? Good. Conclusion. What's x minus 6? It's a vertical asymptote. Why? Because it didn't cancel. X cannot be. Conclusion about x plus 1?
Another vertical.
Another vertical asymptote, sad clown face. X cannot be. Don't force things to cancel. If they don't cancel, they don't cancel.
Not that people.
How are we feeling? Okay. What's the first step for horizontal and oblique asymptotes? Analyze the degree. What's the degree on the top? What's the degree on the bottom? So that's degree over degree. Case 1, 2, or 3? 2. Y cannot be something. How do we get out the something? Highest exponent, we look at the coefficient. What's in front of the x squared on the top? Imaginary one that we don't see. On the bottom? Imaginary one that we don't see. So y cannot be 1. Y-intercept. Ignore or cover everything with an x. What's left? Negative 3 on the top. Negative 6 on the bottom. Reduce it.
Positive a half.
The y and x intercepts are usually going to be pretty tiny numbers, so don't let that freak you out, because you got to remember they approach the asymptote that's usually on the x-axis. So these are never going to be numbers like 5 or 6 or negative 10. They're usually going to be fractions and really small values. X-intercept. Ignore everything on the bottom. Why do we ignore everything on the bottom? Because when I multiply it over, it's going to cancel with a 0. It's quadratic. How many ways are there to solve a quadratic? What are the 5 ways to solve a quadratic?
Factoring, completing the square formula, square root, and graphing calculator.
Which is the easiest one to do with a question like this?
Graphing calculator.
Except this would probably be a non-calc question. Factoring, because we've already factored it over here in step 1. X equals? And again, I like to write them as a coordinate pair to remind myself these are points on the graph, not asymptotes, not anything else. That is all the theory you need to be able to do what we're going to do this afternoon, which is actually draw the graphs. You need to be able to find vertical asymptotes and holes. You need to be able to find horizontal or oblique asymptotes, and you need to be able to find intercepts. The last thing I just snuck in here, because the curriculum says I have to do it, is solving these graphically. We did algebraically last year, so we don't need to do it again. We just need to do it with the graphing calculator. It's exactly what we did yesterday with radical graphs. How many methods are there? Two. What's method number one? Don't call it method number one. Left-hand side, right-hand side. What's method number two? All on one side. Andrew.
Could you zoom in a bit so I can see what I'm putting into the calculator?
Is that good? We got to pick a method, so we're all doing it the same way. One or two. Ooh, that was like consensus like that. Okay, what do you want to put into y equals? What do you want to put into y2? Now, if you've got the new operating system, you can do it as a fraction. If you've got the old, like me, you need to bracket the top, bracket the bottom. Oop. Sorry? Go into second function format and turn axes on. What am I going to press now? Zoom. Oh, how cute are you? What is going on here? What is all of this? Scary when you haven't really seen a lot of rational graphs yet. So the line is pretty obvious. That's got to be the top because that was, or y1 because that was x plus 6. What is the rest of this? Well, it's just the asymptote and it's a volcano. So this kind of squiggly, half-looking vertical line is how the calculator draws asymptotes. Sometimes it can do really nice asymptotes and they'll come out dotted and they'll be perfect. Sometimes they'll come out jaggly and nasty like that.
Can we put this down on to demonstrate?
Here's the better operating system when it looks really pretty, but you can't see. Oh. Well, it looks really pretty anyway.
Looks like you got.
Mine looks jaggly and nasty because it's the old operating system. You just need to be aware of that jaggly, nasty line is just an asymptote. That's all it is. So when we sketch this, I've got the line going like this. I got a volcano piece coming up. I got a volcano piece here. And I'm not even going to draw the asymptote because it has nothing to do with what I'm about to do. If you want to draw it, you can draw it, but it doesn't affect where the graph intersects. You just need to be able to recognize that's an asymptote, although it doesn't look like it. So step number one is drawing the graph. What's step two? What's the second piece of work I need to show? Okay, so there's going to be one here and one here. There's nothing on my other volcano piece. Because remember, it goes like this, but then this is a variation of volcano because it's a one vertical asymptote graph. How do I actually find these points? Second calc, intersect. I'm just going to move closer to 1 because sometimes if you're too close to the vertical asymptote, calculator gets all confused. Make sure you check for your rounding instructions. Confirm negative 1.6. How do we find that other one? And just move closer to the second one. This isn't left bound, right bound. It doesn't matter as long as you're closer to it, the calculator understands what you're trying to do. Negative 4.4. 10 minutes left. That would have been helpful had I put a page number, but I did not put a page number. Let's find out a page number. But on questions 5, 6, 7, and 8, they all have A, B, C, D. I want you to do 1 for question 5, 1 for question 6, 1 for question 7. So you're just trying 1 of each of these once I find you a page number.
As long as I turn down the brightness.
Oh.
We'll see whether it works.
Oh, that's better. Look how pretty that is. But it didn't even give the asymptote. Calculator's a little funky with asymptotes. But that's so much prettier. Look at that. Thank you, Andrew. Wait, let me find you a page number. Page 115. Page 115. For 5, 6, 7, and 8, pick 1 of A through D. A is usually the easiest, D is usually the hardest. Judge yourself in between what you want to do. You're best practicing 1 for each of these. Page 115, 115, page 115. Questions 5, 112, yes.